Okay, let's give you guys some more practice. So establish whether or not this series will converge or if it will diverge. So press pause and have a go. Okay, what we've been asked to do here is to sum up all the terms. So what we've been asked to do is get this term, add this term, add this term, add this term, add this term, and so on. So we're going to map a function on top of all the terms. So we're going to we are going to map this function on top of all the terms. So we're going to map this function on top of all the terms. So we've been asked we've been asked to sum up all the terms. We've been asked to sum up this plus this plus this plus this and so on. So we're going to map this function on top of all the terms, and then ultimately later on we want to make use of that theorem which you've seen in the past, where we would compare this to this integral. If this thing here diverge, then this will also diverge. If this thing here converge, then this thing here will also converge. But before we do that, if we want to decide whether or not this thing will converge or if it will diverge, the first thing we should do is check this. Make sure that the limit of this heads towards 0. So as n tends to infinity, make sure that this thing here, make sure the limit heads towards 0. So suppose you have this as n tends to infinity of 1 over n squared plus 1. Suppose this thing here doesn't head towards 0. Let's just imagine it heads towards 2. So what's happening is that each step of the way from 1 to infinity, you're adding 2 into your total summation. You're adding another 2. You're adding another 2. You're adding another 2. So eventually this thing is just going to get bigger and bigger and bigger, meaning it will diverge. So the first thing we should do is to check this. Make sure that it heads towards 0. In this case, it heads towards 0. So we know that it's not going to diverge. If it heads towards, let's say, 7, then we can immediately say that, the whole series will diverge. So we don't need to do all this here. Okay, so the first thing we should do is to check that the limit actually heads towards 0. So as n tends to infinity, n squared will just get bigger and bigger and bigger, meaning this whole thing here will just get bigger and bigger and bigger. So 1 divided by something that's getting bigger and bigger and bigger, eventually this thing here is going to head towards 0. So this is good. The limit is actually heading towards 0. So now we know that this thing here is not going to diverge. Okay. So now we need to make use of that theorem that says that we now want to make use of that theorem where we compare this with this. The theorem says that if this thing here diverge, then this thing here will also diverge. If this thing here converge, then this thing here will also converge. But before we can apply that theorem, we need to check these three. In order for us to make use of that theorem, we need to check these three. So, in the domain from 1 to infinity, is this function continuous? Which from 1 as x increases, this is going to be nothing really breaks down. This thing here, nothing really breaks down. So this thing here is it is going to be continuous. Now, is it going to be positive? Well, from 1 as x increases from 1 to infinity, is it ever going to enter the negative realm? It's not, because as from 1 to infinity, as x increases from 1 to infinity, this is going to be positive. If you add a positive 1, then this thing here will be positive, and the number 1 is always positive. Therefore, the whole thing here will always be positive. So this thing here will never enter the negative realm. It will never enter the negative realm. And then the third thing to do is to check, is this thing decreasing? Is this thing decreasing? Well, we can look at the derivative if we want to, but this is quite straightforward, so we don't need to differentiate it. We can just look at this function straight away. So is this function decreasing? Well, as x increases from 1 to infinity, this is going to be positive. It's going to be positive, and it gets bigger and bigger and bigger. Add 1, the whole thing here is going to get bigger and bigger and bigger. 1 divided by something that gets bigger and bigger and bigger, meaning the whole thing will just get smaller and smaller and smaller. It is decreasing. So this is going to be continuous. It's going to be positive. It's going to be it's always going to be decreasing. So because all these three are satisfied, then we can apply the theorem. The theorem states that if this thing if this thing here diverge, this will diverge. If this here will converge, then this thing here will converge. So now because these three have been satisfied, we can apply the theorem. So the next step is to check whether or not this thing will converge or if it will diverge. So let's integrate it. So integrate it from 1 to b first, and then later on take the limit as b tends towards infinity. So so to integrate this, remember if you differentiate inverse tan of x, it will give you 1 over x squared plus 1. So now I'm asking you to integrate this. Then of course it's going to be inverse tan of x. So integrate this. Hang on. So integrate this. It will then give you this. Now put b into here. Put 1 into here. That will then give you this. So when you integrate this from 1 to b, it will give you this. Now take the limit as b heads towards infinity. Then the minute you take the limit as b heads towards infinity, this thing here will become rather than 1 to b, it's going to be 1 to infinity. Okay, so the minute you allow b to head towards infinity, we are integrating from 1 to infinity. So looking at this, inverse tan of 1 is going to be a number. It's not going to diverge. It's not going to get bigger and bigger. It's going to be a definite number. So now as b heads towards infinity, well, if you look at the inverse tan graph, it looks something like this. It looks something like this, and then you can see that as b heads towards infinity, it is heading towards a limit, and this limit is pi over 2. So if you integrate this, if you integrate this, and we've done this many times, it gives you this. So this thing here it converges to pi over 4. So that means this thing here is going to converge. Well, looking at the theorem, if this thing here converges, then this will also converge. So this thing here, the series will converge because this thing converge. So therefore, this thing will also converge. Okay.